Kelly. I'm Hajo Eicken. I'm with the International Arctic Research Center at the University of Alaska Fairbanks, and I'm a co-chair of the Executive Committee for the Arctic Observing Summit. And so I was asked to give a brief update on where we're at with the summit, and specifically ask for people's participation. So I just have a couple of slides I was going to share. So you should be seeing just a brief overview slide. What's the Arctic Observing Summit? It's a biennial gathering. It's a bottom-up effort that's meant to support design, implementation, coordination, and sustained operation of observing efforts at the international pan-Arctic level. And it's very much a collaborative effort. So the idea for the conversation today is to give you a brief update on what specifically you can do to get involved, either directly by attending or remotely, with the Observing Summit that's coming up in Akureyri, March 31st to April 2nd. That'll be the 5th Arctic Observing Summit. It's part of the Arctic Science Summit Week. The AOS is an effort that is part of the Arctic Council's Sustaining Arctic Observing Networks initiative, but it's jointly overseen by SAON and the International Arctic Science Committee. The summit, if you've participated in previous summits, this year is going to be somewhat different because we'll get to work on a broader set of documents and efforts that have been led by SAON with involvement from a bunch of other groups that are aiming to bring together and create a framework for convening the range of different observing activities and have them coalesce around a more centralized common sets of purposes that also relate to key priorities, both by the research community as well as a broader society, as expressed in societal benefit areas or societal benefits. There's 5 working groups that you can get involved with, both prior to the summit and during the summit and after. And I'll briefly review those here in a minute. And we had a call out for white papers. Those white papers are now posted online. I'll briefly review where those are at, how you can access them. But this presentation here, I'll submit as part of the documents from this call here, so you can reference this later as well. What's the output from the summit going to be? Well, part of it is to actually get the SAON road mapping process underway, help build partnerships that are going to drive implementation of various observing efforts, and then also in the near term provide input to the 3rd Arctic Science Ministerial that'll be co-organized by Iceland and Japan and hosted by Japan and Tokyo in November of this year. So rather than go through a lot of presentations, let me just show you how you can get more involved by visiting the website. So if you go to the AOS website, here's the entry page. There's a few documents and reports that give you a bit of a perspective if you haven't followed previous summits, with highlights both from the 2018 report and then the synthesis report. But the key point is, as I mentioned earlier, are these different working groups. And I just briefly want to review those here. There's 5 of them. The first one is focused in particular on observing system design, optimization, implementation. That's led by Alice Bradley, Roberta Pierazzini, and myself. And we've also been the group that's essentially tried to connect better linkage to the broader road mapping framework. So if you're wondering, well, what is the road mapping framework? I'll give you a brief perspective on that here in a minute. Working group number 2 is led by Mary Beth Murray. That's very much focused on observing efforts in support of adaptation and mitigation actions. So this has both government, private sector, foundation involvement. Working group number 3 is co-led, and actually I see this now needs to be updated, by Rachel Daniel and Gunbritt Redder. both Indigenous Arctic experts. The focus here is on Indigenous food security specifically, and I'll show you a bit more or talk a bit more about this here in a minute. Working Group 4 is focused on data. Peter Pulsifer is the lead for that. He's also the co-chair of SAON's Arctic Data Committee and one of the co-organizers of the Polar Data Forum. So that process is tying into the Observing Summit. And then the fifth working group or theme is focused on Arctic observations in the context of global observing initiatives. And we, under leadership of Thorstein Gunnarsson, the outgoing SAON board chair, there's a number of global initiatives that the Observing Summit has been coordinating with, and I can give you a brief perspective on that as well. So just to be a bit more specific here, let me just show you the a few key documents that you can access through the website as well. So one of them, first of all, is the guidance document that I mentioned earlier. This is a document that basically helps get everybody on the same page in terms of what is the SAON roadmap for Arctic observing and data systems, or in short, ROADS. This document has a bit more information also on how this ROADS process and the various involvement of working groups and individual entities is going to help us bring together this current network, or some might think of it as a patchwork of observing, how this will be evolving to a more focused or coordinated effort. The document also, the document also is providing a bit more perspective on how the Arctic Observing Summit is actually going to do that. I'm not going to go into details here. But I do want to mention that this already contains specific charges to the different working groups. So these 5 working groups that I've mentioned have already started work. And at the summit itself, if you participate, what you will be seeing is this type of guidance, and that is some of the deliverables that these working groups will be working on to help fill in key pieces of the SAON road mapping effort. And those pieces that are going to be put together at the working group level at the summit, I'm showing one element here that will focus on what we refer to as essential Arctic variables, so that the groups will actually help both identify a process by which we can winnow these down, and ideally already provide a low-level version or a first rough version of sets of these essential Arctic variables. So that's one set of activities. And then the others is to create a broader schema within which, as a follow-up to the summit over the course of the next 2 years, the international community working with SAON can actually make progress on implementing more coordinated observing strategies for these essential Arctic variables. So that's one set of activities. The other thing I just wanted to briefly share with you is the actual AOS program. So this gives you a perspective on the types of things that we'll be covering at the summit. So there's a mix of breakout sessions for the different working groups here, and a set of keynotes, and some of the keynotes revolve around also getting additional support through the Arctic Science Ministerial process. So we're actually leading this off. This is now confirmed by one of the Japanese co-organizers of the Arctic Science Ministerial process. We'll have the Icelandic Minister for Environment and Natural Resources speak, and the meeting is going to end by perspectives from the Icelandic Minister on Science and Education, who will also help us hone our recommendations as input for the Arctic Science Ministerial, where we're hoping that this group of 30-odd countries that's coming together in Japan later this year may help move some of the specific action forward as well. So the final thing I wanted to mention is how can you get involved? So all of these working groups, if you visit the AOS website, have more relevant information on there on how to get in touch. There's an email here that you can use to either contact co-chairs if you know them personally. There's also more detailed information here that you can work on. So we're looking for both participants in the different working groups at the summit itself, but also both prior and after and some of the follow-on activities. Those activities are informed by the white papers that you can access at the summit. So for each working group or sub-theme, we have a nice mix of white papers and brief statements that help prepare for some of this. I just wanted to highlight one in particular here, just to give you an example of the types of contributions we have. So we have a paper by Doug Kripe, who's the chief scientist or scientific lead for the group on Earth observations, and Ian Jarvis, who heads the Global Agricultural Monitoring Program. So they've contributed a nice white paper that basically shows how GeoGlam, and the Arctic observing community can better collaborate. So there's several of these here. Another one is a series of papers from Inuit Circumpolar Council, Alaska, that relates to food security, provides good background and priority perspectives here. So those are the types of things that we're sharing prior to the summit. I think with that, I'll wrap it up. I do want to recognize that there's a number of other people who've been essential in helping move this forward, not least Sandy Starkweather, who's playing a lead role both as the executive director of U.S. Arctic Observing Network, USAON, but also in her role helping lead the SAON board, and a number of other people that have contributed. So let me stop the share here, and if there's time, I'd be happy to take questions or discuss specific aspects in more detail.
Hi, thanks. Yeah, one question. So is it your expectation that most participants will engage prior to the conference, or sort of get there and self-select, or do the organizers of each of those working groups have a running list of people and sort of organizing it in advance so that it's not all crammed into 2 days? Maybe some groups are doing it differently. Any insight there?
Yes, that's a good question. So some of the groups are already convening at least a core group of people prior, so that we have good geographic and background diversity balance. The one I'd like to highlight is Working Group 3. The formal name is Food Security and Indigenous Concerns. So that's co-convened by Rachelle Daniel, Gunbert Redder. They've started meeting in December and have a series of pre-summit meetings, I think a total of 6. They already have about a dozen Indigenous people who are part of the team, a few non-Indigenous. And if you're interested in that topic in particular, again, I'd encourage you to contact through the website, or directly if you have contact information, Rachelle and or Gunbrit. With some of the other groups, for example, let's look at Working Group 5, that's co-chaired by Thorstein Gunnarsson. There's been background conversations with GEO as well, but at a fairly limited level. That's where we're actually hoping to have a more meaningful conversation at the summit, where we'll have representation from GEO leadership as well. So it varies a bit in terms of how people can get engaged. But in general, if you have a particular topic that you're interested in, my recommendation would be, regardless of where they're at, get in touch through the working group leads prior and see how to get involved.
Great, thanks. It's helpful.
Hi, Hajo. I had a question. So is it up to each of the working groups how they're engaging with their participants?
Yes, other than the guidance that we were providing in terms of this roads framing document and the kind of, if you will, sort of the instructions for engaging in the summit, the different working groups have kind of different cultures, if you will, right? So I mentioned the Indigenous Food Security Working Group, so they're very, very much concerned about ensuring that different Indigenous perspectives are being recognized and have sort of have an equitable share in helping shape the summit. That I'm excited about that working group also because at the same time, they're also looking forward and there's a larger group of them that's already laying out what needs to be done afterwards, after the summit, to, for example, muster some of the observing system simulation experiment resources or some of the more engineering design, observing system engineering design perspectives to help inform the information or help satisfy information needs of those who have concerns about food security, both on the Indigenous side, but also from the perspective of resource management agencies, say. And we'll, you know, in the coming weeks, as we're moving towards the summit, we'll probably be able to say a bit more about how exactly that's gonna move forward.
Yeah, that was going to be my follow-on, is how are we going to mobilize so that after the summit, things kind of keep moving forward. Glad to hear that people are already thinking about it.
Yeah, and I mean, the other thing I would also encourage people to think about, in particular for this group, the Arctic Science Ministerial has a process where you know, researchers who are not affiliated with a particular sort of ASM specific activity can still submit ideas or guidance on what they see as potential priorities for the Arctic Science Ministerial to consider. So if you visit the ASM3 website, there's a form for that as well. So that's another way of helping if you have specific concerns about or suggestions with respect to observing system design implementation. That would be another channel I'd encourage you to contribute to, because we're hoping that the ASM is going to be helping, you know, actually move things forward and make resources available as well.
Okay, are there any other questions for Hajo?
I mean, if there aren't, I see Sandy is on as well. I don't know whether you want to chime in on any of this, Sandy. I don't think we have any of the other co-chairs of working groups on here from what I can tell.
Hi, sorry, I had to join a little bit late. I apologize that I missed the kickoff. So I caught most of what you said, Hajo, and I think that's what we were hoping for a just a reminder about the AOS and engagement, that if people wanted to plug into these working groups, that they understood how to do that, and that, you know, it's the vision is really to move towards more of a process that people can be more continuously engaged in, rather than kind of boom and bust planning for a meeting. So no, I'm happy to field any questions specific to SAON and the roads process, but as I said, I sort of missed the very beginning, and sorry about that.
No, thanks, but it's, yeah, it's a good reminder that we are moving away from having a meeting every 2 years into something that's more process oriented with key partners, both at the national level here in the US and internationally. And so if you don't know what the AOS is about, you know, but you feel that this might be relevant, I encourage you to get in touch with either myself or others. I'd be happy to provide more background, but now is a good time to become involved, because SAON then basically is going to be the international engine that'll help move things forward towards a more integrated and internationally coordinated observing system.
Hi, this is Allison. I just had a comment. I wanted to thank you for making this process accessible. And I was a little bit curious about how those of us that probably won't be going to AOS might be able to engage remotely. Will there be sessions available? Also just to note, I think it's fantastic that a lot of synergistic activities, with the Arctic Data Committee, that were carried on through a series of Polar Data Forum meetings and the Interoperability and Federated Search Working Group sessions. I think it's great that there'll be opportunities for some of those activities to coalesce in person at that meeting. But I think there's a broader community of people that would love to, remotely connect to a couple of those sessions and to
Yeah,
what
no,
that could look like.
Yeah, okay, so I don't have the details. I mean, that's something that the Icelandic organizers at Akureyri are working on. As far as I'm aware, unfortunately, we cannot make all the working group sessions fully accessible. The focus is on the plenaries and finding a way for those who are not participating in person to submit comments to the working group chairs. The hope is that by clearly laying out within what framework we're going to be operating. So I briefly highlighted the essential Arctic variables component of the roads or the roadmap process. So the idea is going to be that both some of the white papers already address this question, but that people who are not at the summit can still submit comments on their priorities with respect to how to identify essential Arctic variables, or even, what do you see as key elements? But again, it's not just the summit and the run up to the summit, but then also the time after the summit, where we'll be using, both existing meetings. So for example, last year we had it was the year before last, had a workshop just prior to AGU. So we'll be using those types of forums within the US, for example, to make sure that we're pulling in those who weren't able to go to Iceland.
That's terrific. Thank you.
All right, well, thank you so much, Hajo. We'll be sure to keep engaged as we get closer to the summit. Is there anything else for him?
No, thanks a lot, Hajo. That was real helpful.
Okay, with that, I think we'll turn it over to Matt Shupe to talk about his experiences on MOSAiC.
All right, so I guess you instructed me to put up some pictures and what have you. I don't really have a whole lot of prepared remarks, but I will share a couple photos and a few things you asked me to talk about. The initial installation and some of the kind of met installation that we've done out there. And so I'll do that kind of briefly, and I'm happy to entertain any questions. So can you all see the screen fine? Okay, so I'll just have a few pictures here and just kind of say a little bit about how things went. So I hope you all know about MOSAiC. MOSAiC is a project where we're taking the polar stern, the icebreaker that's pictured here, and freezing it in the Arctic sea ice for a full year. We left from Norway, northern Norway, on the 20th of September. To great fanfare. There was a big farewell event, unlike anything I've seen before for any kind of research I've been on. So it was pretty amazing there, actually. And sailed out into the Arctic Ocean. We, over the course of the next couple of weeks, got into the sea ice, kind of broke our way into the ice, and started heading kind of towards the North Pole from the Siberian sector into an area that we kind of projected as the best place to start a year-long drift as part of the transpolar drift path. So heading through the ice, we saw all kinds of ice flows, of course, and as we got further north, they were getting bigger. We were on a search for an ice flow that would be stable enough to have a year-long project out there looking at the ice itself and all the other factors influencing the ice, like the ocean and the atmosphere, and the ecosystem that's within the ocean and ice, and so on. I forget what I have here in my slides. So I'm just going to show some more pictures. Here's a picture of the ship. You can see, I don't know if you can see my mouse there. There's the ship kind of in the middle of an ice flow, one of the flows that we were looking at. It was actually pretty challenging initially. We had the polar stern icebreaker out there. We also had a Russian icebreaker as well called the Fedorov. We were going together with tons of people and equipment out to look for flows. It took us a while to examine a number of flows. We stopped at some and made a lot of thickness measurements. Here's just an example of the first day that we actually went out on the flow that we ended up at. This was a little team of us that were going to make some thickness measurements kind of spatially to look at what this ice flow was, what kind of condition it was in. What we ended up finding was actually a challenge. We evaluated quite a few different flows over an area and found that there was a lot of ice, kind of like what I'm showing here, where near the top, we are already into the freeze up season. So there was some fairly solid ice near the top, but a lot of rotten ice underneath. And so a lot of these flows also had this kind of structure that it looked like there was approximately a 70% melt pond fraction back from the melt season that had been frozen over. So, and most of those melt ponds were frozen through. So you actually had about 30 centimeters of ice on these former melt ponds that were frozen through. And then the skeletal structure in between was pushing, sometimes up to a meter thickness, but very rotten ice for the bottom part of that. So pretty kind of skeletal structure of weak ice with all this new thin ice. Not what we were looking for necessarily, but this is what we found everywhere. So this is pretty representative of the kind of ice that we found in the area. In the end, we decided on a flow and we decided to go forward with that. I'll get into that in a minute. But after we decided on the flow, the Fedorov went out and installed our distributed networks. This is a kind of a spatial array of measurements that was around the primary facility. So here's a picture of the Fedorov in the background with, this is a sled that we built here in Colorado that's looking at surface energy fluxes. We put one of these out at some of the stations. There was a number of other buoys installed in the distributed network. Here's a map of the distributed network. So C in the middle is where the central observatory is, where the polar stern is parked. And all these other assets were put out, and you see these range rings and kilometers extending out. So tons of stuff put out in this network that's around the polar stern. The L sites, L1, 2, and 3, are pretty sophisticated, our large sites have a lot of really major buoy assets. The M sites are medium sites, so some buoys, some smaller systems, and the P sites are basically position buoys. So you can see there's different sizes and different length scales away from the ship. Fantastic. They put this whole thing out in about a week. It was really amazing. Nice work on the Fedorov side. Back for the polar stern, this is our ice flow. This is it's probably hard to make out much detail, but that's fine. This is a laser scanning map. We flew helicopters around to do laser scanning of the surface. You can look at the flow, and so the flow is kind of outlined in white here, and you can see that the ship is actually right here. This white arrow is where the ship is parked. And one of the distinctive features about this flow and why we selected it was that there's this area that's all shows up kind of white in the diagram here, and this is what we've called the fortress. And on our initial forays onto this ice flow, I was walking in there with some different teams, and it was just gnarly and ridgy and really thick. We took a snow machine in there on kind of day 2 and tried to get through, and I was afraid we couldn't even make it through with a snow machine. So lots of thickness in that area, and the rest of the flow kind of down to the bottom part of the picture was this thin ice, lots of former melt ponds. And so the bottom part's more probably what we were looking for to study. We weren't necessarily there to study a lot of ridges, but the ridges were the most stable thing we could find. And so we decided to park near the fortress and use that as stability to then put our assets out kind of near the edge of that and explore the thinner ice around that. So that's kind of the approach that we decided to take. So here's the polar stern. We have a lot of equipment on the polar stern. You see here a nice tower that's off the front for sampling some air. There's all these containers. There are 30-something sea containers on board, or even more, Lots of atmospheric equipment here in front of the ship. Some nice radars installed up top from the ARM program from DOE. Then here's going to be a few pictures of setting up our Met City area. This was something that, Kelly, you asked me to talk about a little bit. So Met City is one of our cities out on the ice that we're making measurements of a variety of, it's Met, meteorology city, but it's actually, this was an interdisciplinary city out there. It was really fantastic. I'll show a couple pictures of the different components there. So this is some of us building a Met tower out at that site. Here's some radiation measurements. You can see the ship in the background there. These are from the Department of Energy program. A couple other buoys installed there. On the right is an ice mass balance buoy. On the left is some of the ocean flux buoys from Tim Stanton's group. Both of those are funded by NSF. And so out at Met City, we had ocean measurements, we had ice measurements, atmosphere measurements. We had people looking at gas fluxes, biogeochemistry. We even had a fish camera for people doing ecosystem research. So it was really an interdisciplinary site out there at Met City. So much more that I'm not able to cover here in great detail. Here's Byron Blomquist looking at some gas flux measurements. This is inside the Met hut, so we had a little shelter there that we could have some warmth and some kind of protection from the elements. Here's looking off to the left, you can see the Met hut. You can see the tower we put up. You can see some of the DOE facilities, radiation measurements, and there's some precipitation sensors, and you can see the ship in the background. And you can also see that it's dark. It was dark for most of the time. In kind of mid-October, the sun went down, and it was down, it's still down now. It will be down for another, more than another month. So a lot of darkness there. Although you do see that nice full moon up there in this picture. We did have a big event. Actually, the ice is fragile. This is something that, I think we were prepared for thin ice, but nobody was really prepared for what we found. Even for all of us seasoned Arctic researchers, it was still kind of pushing the limits for us. The ice fractured all the time. It was a dynamic situation. This is a picture from the bridge of the ship looking out. You can see some of our assets kind of on the far side. These are, many tens of meters across these big leads. They're right between the ship and a lot of, Met cities on the other side, for example. So we had to deal with these kind of circumstances a number of times, kind of big ice dynamic events. A big shear zone went right through the middle of the fortress, right through the middle of our camp, and it took down all of our power system. And but this came together, and ever since it came back together, things have been pretty stable and everything's operational. This was kind of the middle of November. We had a nice big storm. It was really a great event, actually. So here's a picture from the bridge right before we left, kind of a little bit magnified, but you can see there's Met City out there and some of these towers, and you kind of see power lines. There's some people standing out there with reflectors on. And this is just kind of one sector looking out from the bridge. There's other sectors to the other side with other science equipment. And you can kind of, at the bottom part, you see some of the ridges after things started to come together to close up that big dynamic event that happened. So this a map of kind of how things currently look there. You can see the polar stern sitting there. In the back is laser scanning, but then we see all these annotated details, and all the red lines are basically our roadways and power line ways that go around. We see down here is Met City, that's forward of the ship. It used to be way out here. Can you see my mouse there? Kelly, if you nod, and yeah, there we go. So Met City used to be out there, and the shear event went right through the middle here. And so Met City and Remote Sensing City moved way out towards the front of the ship, whereas Ocean City and some other activities kind of stayed where they were. So it was a little bit of a challenge for us there. But again, that's what we're here to study, to look at all these great dynamics and how the new Arctic and the thin ice is affecting the system. So this is the current map right now. It's been stable for we're pushing almost 2 months of kind of stability in this formation. There's still cracks that happen through camp all the time. They've mostly been small and they freeze up quickly. And so that's one of the big challenges. We've had some polar bears come through. That's a challenge, but I think we've managed that pretty well. All in all, everything is going really fantastic, I would have to say. Here's the full team for MOSAiC Leg 1. Right now we've got Leg 2 out there with lots of great science going on. Right now we've got 20 nations involved. We've got science that cuts across the whole Arctic system, looking at the causes of change in the sea ice. and looking at the consequences of that change. So it's really a fantastic experiment, and we're getting some great data. Really look forward to a lot of the kind of cross-cutting analyses that will come out of that. And with that, that's what I prepared. At some point, I mean, there's so many details to this project, and I'm sure people are interested in that. I'm happy to answer questions, and at some point, I'm sure that there will need to be other summaries for other IARPIC committees to kind of discuss different aspects of MOSAiC.
Absolutely. Thanks so much, Matt. This is so fascinating to hear about the shear that came right through. That must have been a little bit of a scary moment for you guys. You have all that expensive equipment out there and kind of at risk of just falling into the sea at that point.
Yeah, well, you know, I guess fear for me that never came into it. You know, if we lose stuff, that's part of the deal. And, you know, in the end, you know, NSF and DOE and other agencies footed the bill for that. And you know, we all know that what we're getting into. And in the end, I think that's part of that's factored into the situation. You know, if we're going to observe the Arctic, we're going to risk some of our assets. And that's just kind of how it goes.
So Matt, this is Molly McCammon. What great presentation. I've been following all the communication materials. I'm on the weekly update and everything, and it's just really super cool. But what would you say, what was your biggest surprise that you just totally unexpected?
Oh boy, that's hard. There's a few. I mean, one is the ice, right? Which is strange because we all expected thin ice, right? We were going into it expecting it, but you know, we were there with 2 ships full of a lot of experts, specialists in ice, and we were all kind of a little bit befuddled, like, wow, we can't really find what we're looking for. And so that was, you know, surprising, even though we were prepared for that. Another thing that's really fascinating, and I'm pleasantly surprised by, is, you know, this is highly international. And, you know, in today's day, you look on the news, unfortunately, we were kind of cut off from the news out there, but you look at the news and it's just discord, you know, among nations. And out there, we were such a fantastic team. And there was, you know, Chinese people and Russian people and US and many other nations all working together. And it was seamless. And we were really a team fulfilling these kind of larger science goals, going out on different teams to sample ice or to set up equipment or to move power lines or whatever it was. And you know, you couldn't really tell what country people were from. We were all just working together so well. And so that to me is another thing that I'm really glad to hear it, but I was actually surprised at how well that worked out.
Awesome. Any other questions for Matt?
Well, Matt, given the difficulty you had finding a flow and the fact that so many ice experts were, in your words, befuddled, how representative is this flow of sort of, you know, what you think is happening in that area of the Arctic? In other words, how easily will you be able to extrapolate, you know, measurements you take here to a larger Arctic area, or is it going to be so specific that you won't be able to?
I think it's pretty representative. I mean, what we did, we came together after, you know, this kind of prolonged period of searching with 2 different ships and a bunch of helicopters. And we came together and put all of the different flows on the table, if you will. Said, hey, we looked at this one, we looked at that one. And hey, what we found is a whole lot of former melt ponds with 30-centimeter ice on it and this kind of skeletal structure. And that we found that time and time again, which is not what we wanted, right? I mean, we wanted some thick ice that was stable and hopefully there's some thin ice close by. But in the end, everything we found was kind of the same. And we ended up, you know, going with this one flow that had this kind of thicker core just for the stability, which, you know, that thicker core, you know, we thought was not going to be representative. But you know what? After all these dynamics happened, here are all these new ridges forming that look an awful lot like that thicker part that was right over on the other side. So I'd have to say that, you know, my best guess is that it's pretty representative. The spatial area around there is pretty representative of what we were finding in this kind of, you know, much broader regional domain that we were, you know, looking across for different ice flows. And, you know, also it just makes sense, you know, in thinking about it, it makes sense about, you know, eventually the ice gets to a, you know, it gets thin enough that the melt ponds mostly melt through, right? And that's a transition kind of thing where, you know, a couple decades ago, you know, melt ponds didn't melt through that often, but now they do a lot because the ice is just overall thinner. And so eventually that's just kind of how things are going to be. And so finding this, you know, 70% melt pond fraction with most of them melted through is probably pretty representative right now. And so, you know, I feel like what we're going to learn there is actually going to tell us a lot about the current Arctic system and, you know, this kind of dominated by ice that's no more than about a year old.
Great, thanks.
This is Sandy. I know one of the objectives when you set out on the expedition was to test out a lot of new technology that would maybe enable more autonomous studies, you know, given it was out there such as it was to do the wintertime studies. Are there certain technologies that you can point to that you think, yeah, this is looking like a next generation approach for how we could do this potentially unpiloted, autonomous, and still get some pretty valuable science results moving forward? Yeah,
you know, there's been a lot of interviews and things lately, and that's one of the things I've been saying is that we're not going to be able to do this approach much longer. In the end, the ice is not going to support putting a whole lot of heavy assets out there that aren't autonomous. So it's definitely important as we think about Arctic observing to keep, you know, pushing forward on this, you know, developing autonomous systems. I have the personal experience of some of the stuff that we worked on, right? So we built these surface atmospheric flux stations that are right now on sleds. They could be, you know, built into a buoy platform. But, you know, some of the big challenges that we had to overcome were icing on radiometers, remote power systems, things like that. And they've really turned out amazingly well. I'm surprised at how kind of robust those systems are, how we've been able to mitigate the ice buildup on some of those stations. Whereas, you know, at Shupe 20 years ago, that's every day we'd go out and clean these things every day. And it was like our biggest activity. And now we don't have to do that at all. And these systems can operate. So that's just one nice advance that I think we're moving towards the ability to do, you know, some of these remote measurements in that way. I will say though, that there was a lot of hands-on out there, and that's kind of why we need the people there. A lot of the kind of detailed work. And I think that it'll be a challenge for us as an observing community to figure out how to combine optimally these kind of autonomous systems to get you know, a large chunk of the information we need while still getting out there to do some of the hands-on work, because, you know, there's a lot of laboratory work, there's a lot of physical sampling that is very essential to understand some of the details. And we're not really there yet at doing that remotely and autonomously. So I think it's got to be a balance going forward.
Hey, Matt, there's a question from Olivia. There's a lot of great public outreach on MOSAiC. Have there been any inquiries for data from researchers not involved in the project design and implementation?
Has there been inquiry for people that are not involved to get the data?
Yes.
Yes, certainly. I mean, all the time, there's lots of people. And yeah, it's interesting how the data is working here. You know, I've definitely been promoting a very open data policy. And a lot of the, you know, certainly the European colleagues are a little more on the kind of closed policy. And so we're kind of pushing back and forth. So right now, there's what's called the MOSAiC Consortium, and those are people that are contributing to MOSAiC in some way and then also have access to all the MOSAiC data. There's going to be a couple-year period where it's kind of a little bit limited to who can participate unless individuals or institutions release their data before that. So I know that many of the US ones will be releasing their data to anybody much before, you know, earlier than that. So there's a lot of people that are trying to become part of the consortium, and there are, you know, there's a way to do that. And yeah, other interested parties should contact the people that they're interested in working with or the data streams they're interested in working with to see about getting a hold of those. I personally things I'm involved in, we're trying to get the data out there as soon as possible, because in my opinion, the success of MOSAiC is not about me and my project. It's about us and our ability to study the Arctic system. And it's such a highly collaborative project that we just want to get as much of that information out into people's hands as possible so that we can support all kinds of different research.
Hi, Matt. This is Allison with the Arctic Observing Viewer. I want to thank you for your presentation. And just to let you know, we've been in touch with Ann Gold, Stephanie Shoemaker, and folks at the Alfred Wegener Institute have been very helpful in sharing near real-time access to the Polar Stern ship track. I had a couple questions. I realize that you have a nice data archive through the library, and we're interested in capturing a time series, for instance, of the distributed network of the buoys. And would the best archive be to go through the Alfred Wegener Institute, or should we be looking at the International Arctic Buoy Program archive for that type of information?
Yeah, I think going through AVI, the Alfred Wegener Institute, is kind of the most official pathway. They are hosting through Pangea the kind of official MOSAiC data archive. So I think that's kind of would be the official way to do that. There are potentially some less official ways to do that. A number of individual people that have buoys in the distributed network, that's many of those are funded by NSF, for example, and that data flows through their web pages, and soon enough will flow into archives in the US. And so there's multiple ways to get parts of that data, but the kind of official MOSAiC thing is to go through AVI.
Okay, so we'll continue to work, I guess, with Stephanie Shoemaker would be the best point contact?
I'm not sure about that, actually.
Okay, all right.
That could be true.
And a related question, on the supply vessels, will there be more sampling going on through other supply ships, or is that just through the Fedorov?
There's a little bit of a different story depending on which ship.
Yeah.
Current ship that's going back and forth is a Russian ship. It's an industrial ship, and the official word is no extra sampling, although there was actually some sampling on the ship going just came out on. There are some plans for potentially sampling on the Odin when the Odin goes in and out, which will be kind of later in the spring into summer transition. And I'm not sure about the Chidlong, which will be kind of in the summertime. So I'm not sure about that one. But yeah, there are some plans for additional measurements on board resupply ships.
Another really basic question. I have a graphic from Frank Rack on the series in the legs. Are those specifically tied to brackets in time, or are they spatial, the cruise legs?
The legs are time periods, right? Those are
periods.
Times when these resupply vessels go in and out. And of course, operating in the Arctic is challenged, so it's plus or minus some slop in that schedule, but that's the general schedule, yes.
Okay, great. Well, thank you. I grabbed some screenshots from your presentation, so I'll follow up with Stephanie.
Okay.
And Matt, this is Bill Manley at INSTAR. If I could jump in also about RMAP and AOV. Our interest in tracking the Polar Stern, but also the paths for the drifting buoys, things like that. It can be really helpful, I think, for a broad community to be aware of everything that you all are doing. It's amazing. And, and some of this comes down to not just seeing the data as it's released, but knowing perhaps ahead of time about what's being measured where, essentially, or ties into the whole idea of a roads process for essential Arctic variables.
Yeah, and the MOSAiC archive is going to be extremely sophisticated in that regard. There's this whole sensor web where everybody's entered their sensors in there with a great amount of detail, and it maps onto metadata and all the data that will eventually populate under each of those sensors. I mean, in my frank opinion, it's so complex, the data system that's in place there. I mean, I'm sure data people probably just totally are psyched about it, but from the user standpoint or the kind of input standpoint, oh my goodness, so hard. It was like so complicated about entering all these actions and how things would change, and did you change a sensor, and when did you install that sample? And so a lot lot of information that they're trying to pull together, but on the other hand, I think it's going to be extremely valuable information. And so there is this great structure in place that I think will capture a lot of the information you're talking about in a very sophisticated way, as far as I can tell. Some of it's admittedly a bit over my head at this point.
That sounds awesome. And so that's through the sensor web that Pangea is setting up?
Yeah, the sensor web is run by Avi. Pangea is also run by Avi, and those things will be talking to each other. So there's, again, some of it's over my head. I haven't been able to put it all together, but it's a pretty sophisticated system. And the main objective is, how do we get together this whole complicated international project in a way that's going to somehow, be able to have some cohesion to it, and all the data is going to be well represented, well connected, well linked, and then hopefully well preserved and served to the public. And so that's kind of the objective there.
Great, thank you.
Okay, we have about 5 minutes left to the top of the hour. Any last words of wisdom? Otherwise, I'm going to open it up for just some brief updates from the community if anyone has anything to share since our last meeting, which seems like a lifetime ago, before the holiday. Okay, if not, our next meeting is February 19th. And we will see you then, hopefully get an update from Kathy Kuhn on the CMBP project.
Yeah, and I'd like to just thank Matt for his time. I know you just got back from sea or ice. So thanks for taking the time to put that together. That was really helpful.
Yeah, sure thing.
Yeah, enjoy some vacation time, Matt. All right, thanks a lot, and we'll see you all next month.
Thanks, everybody.
Thank you.
Thank you.